So in this example, we're going to look at pushback and popback. What I've done is I've pulled everything down. I noticed in the previous example that first line of our output window was obscured. This time it won't be. We don't necessarily have to pay attention to the CPU RAM and storage in our lower left of our repel window, but it's something that when you hit run, it's worth taking a look at because we're going to lean on the processing power of C++ to be able to ensure that we have contiguous storage locations for our vector. So let's proceed. First and foremost, remember again that you do have to include the vector library here. On line number 8, I'm sticking to integers, so vector and then int inside of my less than and greater than, and then value. So I'm calling my vector of type int values. Now, just like in our previous example, here I have not specified the size of my vector. In this case, it's called values. But unlike the last example where I was using a range-based for loop because I had actually given an initial size to that array of size 5. Here, because I didn't do that, because our vector is empty and has no size, what I need to use is the pushback. So just again, to continue with our plates example, a vector is first in, last out. So if I put plate number 0 on the tray, plate number 1 goes on top of it, ... all the way to plate number 99. So my 100th plate in that pile. The way I remove those plates is 99, 98, 97, because if you start with 1, they're going to, well, crash, and you're never going to be, or you're going to be asked rather to never come back to that buffet again. So what we need is pushback. It is going to take and is going to add an element to that vector at the end. So here in my parens, so values.pushback, remember that's a call to a member function. Pushback is a function of vector that's included with, well, the vector library. So I'm giving it a value of 1, I'm giving it a value of 2, I'm giving it a value of 3. Now, if I was to do this with a user-generated value, I could simply put values.pushback, and then in my parens, whatever the name of the variable is where I have stored that user generated value, and that would work there as well. So let's just run this, and we'll take this. I ran it previously, so it actually ran pretty quick. I'm surprised, frankly. So first and foremost, I have these 3 lines, 11, 12, and 13, where I have pushed to the back of my vector those values. So here, the size of those values is, and I've got this function call here to the member function of vectors that is size. What this does is it returns to me an integer value. That integer value is the total number of elements in that vector. Remember, it's n minus 1. So the first element in my vector is 0. The second element in my vector is 1. The third element in my vector, n minus 1, is 2. So I'm going to pop on line number 17 and 18 a value at the end of, or a value from, rather, the end of my vector. So remember, push adds a plate, pop removes a plate from the end. So you'll notice that my function call there is empty because all I'm doing is removing the last element of my array. So now when I ask for value.size, I get 2 instead. We do it again. Values.popback on line number 23 removes the next, what is now my last element in my vector. And here it is now a size of 1. And finally, at the very end here, it is a size of 0. So we can use pushback, we can use popback to either add or remove from the back end of our vector of value. So the use to you here is irrespective of the size of a data set, it is that you are entering in from a file. In an array, you had to know how many individual data elements there were in that data set so that when you created your array, you had to specify the size of your array. Here, it is perfectly dead simple, frankly, to be able to take a file of size and persistently add to the back end of your vector, to the back, 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 another element. And you can do that ad nauseum until, frankly, you run out of space. But do remember, when you see either core dump or segmentation fault as an error here, from a previous example, I'm just coming back to it now. When you see either of those, what is happening is you are trying to reference a location in memory that you do not have access to. And usually what that means is you tried here with vectors to treat those elements like they were in an array, whereas when you're adding to the back of your vector, you just use pushback instead. So push and pop are really the two things that we are going to use here for the Chapter 7 end of chapter exercises for the vectors. There's only 2 of them. And then you'll live your life here with push and pop in the last project, for which there will be a description shortly. So there you have it, CIS 276 vectors, and they're about this much different than the array.